Okay, in this video, we're going to talk about one of these right here, a firewall. So this is a concrete block masonry wall being built within a building. Here's another image of a firewall within a building. So we'll look at the building code, see what it says about a firewall, and I'll talk about why, for example, this building would incorporate this firewall into the design of this building. We'll also look at this condition right here. So this is a very common approach to building a wall that's right on a property line. So again, you'll see that this is a concrete block wall, and that wall is pretty much right on the property line. So this is very often referred to as a firewall. And it might actually fall into the definition of firewall when we look at the building code, when we look at the definition of a firewall. It kind of describes the situation, but when you go to the section of the building code that talks in more detail of a firewall, it doesn't really talk about this situation at all. And so this is a common approach, at least around Calgary, Alberta, to do a concrete block wall on a property line like this. But it could be something other as well. And again, this is generally built as a firewall, but it doesn't have to be actually. So I'll talk about this situation. This is kind of where I'm heading with this more than the other pictures. I want to kind of flesh out what's going on here. So why is this wall being built this way? Does it have to be built that way? What are some other options for that wall, and maybe some history as to why this is this way and why we call it a firewall? Is it even a firewall? This is kind of where this video is headed. Okay, so what I've got here is the National Building Code of Canada, Alberta Edition, and I've gone to the definition of firewall. And so if you read this definition, it does describe the pictures that we just saw. So it's a type of fire separation of non-combustible construction. So we saw that it's a concrete masonry block in the cases we looked at there, that subdivides a building. So we saw that, or separates adjoining buildings, and it's the purpose is to resist the spread of fire. Okay, so if I jump ahead here to Division B, Part 3, 3.1.10, this is the section that describes firewalls and how they have to be built. So generally speaking, if you read through the prevention of firewall collapse, what this is getting at is that if your building is on fire and let's say your building's collapsing because of the fire, this wall that gets built needs to be able to remain standing so as to protect the building next door. So if your building's collapsing, this wall would stay intact. So you might see that sometimes, maybe an aftermath of a large fire, or even hurricanes and things like this. Sometimes the buildings will be burnt out or whatever, or trashed in some way, and you'll see this concrete block wall, or poured concrete. They can be poured concrete as well. But you'll see this wall standing. So the whole point is that yeah, it'll stand, it'll freestand itself in the event of collapse of the building. Okay, so the next section here is just giving you the required fire ratings of these firewalls. And then there's some articles about continuity of firewalls, so they got to be continuous, and if there's a parapet, it has to go a certain height above the roof, and this type of stuff. And then there's some information on some openings you can have through a firewall, and so on and so forth. So it's a very short section, but the long and short of it is, if you read through this 3.1.10, it's not really describing this situation right here, where you're building a wall on a property line. It's more intended as this wall that's dividing a building into two parts or more. And so the primary purpose of why, for example, this building would have this firewall here is because likely if this wall wasn't here, this building couldn't have been made of combustible construction. So if that wall was not put there, very likely this building would have had to have been of non-combustible construction, so steel construction or concrete construction. And they wanted to build out of wood. So by putting this wall in there, that enabled them to build this building out of wood. So let's take a look at why that is. So that takes us back to section 3.2.2. So now I have another video on this, but on this section. But basically, this is the section where you look at the classification of the building. You look at the building height, how many streets it's facing, sorry, how many stories, when I say building height, how many stories there is, how many streets it's facing, what's the building area. And you know, when you put all these items together, then you figure out, you know, you find out what classifications work for your building. And then when you do that, it tells you whether your building has to be of non-combustible construction, whether it has to be sprinklered, and so on and so forth. So if you're not familiar with the 322 section and classifying a building, watch that video. But that's kind of what it relates to. So probably what happened in this project right here, again, like I said, is that the building would have been too large. So the building area maybe was too large, or you know, maybe the stories in addition to the building area would have made it to a point where it couldn't have been combustible construction. And so where the key to this lies is in the definition of building area. So when you figure out your building area, it means the greatest horizontal area of the building above grade within the outside surface of exterior walls or within the outside surface of exterior walls and the center line of firewalls. Okay, so basically what that's saying is that if you have this building here, you know, you would take the entire footprint of this building as the building area. But if you put in this firewall, then you can treat it like two buildings for the purposes of building area. So, you know, if you had 1,000 square meters on this side and 1,000 square meters on that side, without that wall, the building area is 2,000 square meters. With that wall, though, you can now classify this building as 1,000 square meters on this side and then build it appropriately. And then you can do the same on this side as well. So that's commonly why they're used. It could be one to keep you in the range of doing non-combustible construction. It could also be that maybe you can't or don't want to sprinkler a building. So again, a larger building is going to need to be sprinklered potentially. So if you put in this firewall, it's going to shrink that building area into two buildings essentially, and then possibly you won't have to sprinkler it because it's a smaller building at that point. So that's generally what a firewall is and where they're used. And so as you're walking around, just pay attention to this and you'll start to see these walls being used a lot within buildings basically. Okay, so let's take a look at what's going on here and here and here and here and here and here and here. You get the idea. So these walls being built along property lines, the concrete masonry walls on property lines is very, very common. And so in my younger days, I had projects where I worked, you know, I had these types of walls in my buildings and I was just kind of shown how to do it from the seniors above me. And I was kind of just told that's what we do. And that's the way I would do it. And then one day I had a project where I had done this in the drawings, and the client had said to me, "Why is that concrete block wall there?" And I was like, "Well, it's because your wall is right on the property line." And he was adamant that we not do this concrete block wall. He's like, "I don't want to bring masons into this project. No, we don't need that. Look into that harder. I really don't want it." And I was like, "Okay, I'll look into it." And I was pretty sure that indeed we had to do it. But as I dug into it, I realized, no, you don't have to do this. And so it was actually this project here, certainly not my finest work, but I like to say you learn something on every project. And so again, originally I had shown a concrete block wall here because in this case, the property line actually, there was a sidewalk there, but the property line was actually right against that building face. But what was unique about this was that the client owned this site and owned this site. So there's still a property line there, but he owned both sites. So this wasn't really an issue to do this. I don't think it was a good decision to not do the concrete block wall, but nonetheless, we were able to do this, and I'll show you how that was possible in the code. And so again, you know, the 3110 firewall section didn't really talk about that situation. And then so you would think the spatial separation and exposure protection section would talk about, well, if you're right on the property line, essentially zero, maybe it would refer to the firewall section, or refer to this wall needing to be non-combustible construction, or whatever. But it doesn't. It doesn't do that at all. So really, if you look through it, you just get into your regular charts, whether you're sprinklered or not sprinklered. So I'll just go to sprinkler one. And you have the area of your wall, and your distance, your limiting distance is 0. Okay. And then you keep scrolling through there and you think, well, maybe it's a party wall, but if you go to the definition of party wall, it's like, well, this is a jointly owned wall. And that's not what we have here. The wall's on one side of the property line, so it's not a party wall. And so basically all I'm finding is that, okay, well, I can have 0 unprotected openings. And then you get into the construction of the exposed building face. And, I think that building was a group A. But if if the maximum area of unprotected openings permitted is 0, then you need a 1-hour fire resistance rating. The construction has to be non-combustible, and the cladding has to be non-combustible. But it doesn't say it has to be masonry. So you could certainly do steel studs and steel frame and all that kind of stuff. So anyways, long or the short is, when you look through the spatial separation section, there's nothing forcing that masonry wall on the property line. Okay, so why do we do it? Well, one of the obvious reasons would be because this is not your property, and so you can't actually go on this property to build this wall. Maybe, I mean, you might be able to get permission, but that might be one reason that you would use this concrete block wall. So, if it's concrete block, you can stack concrete block from your side and just work on the one side and work your way up. So that's what's driving that wall. Another reason would be that you want a maintenance-free wall, basically, because this is a good example. I mean, this house will get torn down probably someday, and another building will get built beside this, and you can't have, or you don't want, finishes on there, whether they be, they'd have to be non-combustible, but you wouldn't want to put non-combustible finishes on there that you have to maintain in some way. So if you had insulation and cladding and all this kind of stuff on there, and your air barrier and everything, you might have issues in the future doing maintenance on that or taking care of that. So, this is basically a maintenance-free wall being built here, that you don't have to worry about what happens next door. So I'd say those are two of the primary reasons, and a third and fourth would be why you still need a non-combustible wall. So the masonry is non-combustible, and you still need a fire rating on that wall based on the spatial separation. So you're getting the fire resistance rating with the concrete block as well. And so as I mentioned earlier, they don't have to be concrete blocks. So this is actually a fairly recent build where they did a poured concrete wall. So this is less common, but if you have a large condo tower that's of concrete construction, then generally you'd see a poured concrete wall rather than the concrete block. And so how that's done, it's basically a formwork does go up. So it's called a blindside formwork, and the formwork goes up because you obviously need forms to pour the concrete into. And in this case, they had access, obviously, to take the forms away for most of the wall. But the blindside formwork is just formwork that you just leave there afterwards. So I would assume where this existing building is, the formwork is probably still in there between those two walls. And there's just a closer look. So they've got that right tight to that existing building right there. And so quality-wise, I would say, because you're leaving this exposed, the poured concrete, in my mind, is a far better option for this. I'll call it firewall on the property line, and only because I think over time it would just weather better, basically. So concrete blocks a little bit more porous, and it has mortar joints between the blocks. So things could break down over time, whereas the poured concrete is going to stay pretty solid. So I'm sure this is more costly to go the poured concrete route, but I would say it's a better option if one's being forced into this situation. And so obviously this is pretty ugly, so at the very least it'd be nice to paint it. But you could put cladding on it, like if you pulled your wall like maybe 50 millimeters off the property line, and you got permission from your neighbor to go on their side to install some, say, metal cladding or whatever, some finish. You could do that. And so here's an example of that. So this building right here, this has a concrete block wall in behind this metal cladding here. So it's there, but they've just obviously gotten permission from the neighbor to put this cladding up to make it look better. But behind that cladding is just concrete block. There wouldn't be insulation and stuff on it. So let's take a look at that next. And actually, why there wouldn't be an air barrier and insulation and all that, your normal outside insulated exterior wall construction, that'd be ideal. But the reason they wouldn't do it here is just because this building might get torn down someday and they build right on the property line and you'll never have access to it again, so you can't do maintenance. So they've built it like a normal concrete block firewall where they insulated it on the inside of the wall and just put this metal cladding on top of it. Okay, so let's take a look at how this wall is usually built. It doesn't have to be built this way, but typically what I'm seeing most of the time is that this wall is being built just like this. So this wall is freestanding, just like the firewall requirements. So if the structure on the inside, burnt out this building, when the structure here collapses, this wall would not go down with it. It doesn't have to be that way necessarily. So I've seen some of these concrete block walls become load bearing, but I would say most commonly I see them as freestanding and the steel put on the inside, for example. Now, if you did not do the steel here, you didn't put the beams in and the columns, and you use the concrete block as load bearing. Presumably, I mean, I wouldn't know without talking to the engineer, but presumably that would mean that if your building did collapse from a fire, that wall's probably going to come down with it. So at that point, I would say it's just a non-combustible masonry wall, not actually constructed as a firewall, if that makes sense. So I think in most cases I've seen it constructed as a firewall, which is why I think in industry people call it a firewall. But I've also seen instances where it is load bearing and possibly not. It was possibly not actually designed as a firewall. However, the engineer could probably make those connections work in a way that when the structure failed, that it would not pull a wall down with it. But I have a feeling that's not the case in the buildings I'm thinking of. So most commonly, I would say you see it like this. It's just industry's just decided to build these like firewalls and make them freestanding, and then and put the steel on the inside. So let's take a look at this in plan detail, and I'll show you how typically they're insulated, because you're not putting insulation on the outside, remember. Okay, so what I've drawn here is the blue line here is the property line, and I've drawn the concrete block wall. So usually a 190 concrete masonry unit is used. Many, if not all, of the holes, the cores would be filled with, there'd be rebar put in them and then filled with concrete. And I just pull 25 millimeters off the property line as a kind of a minimum, just for construction tolerances. But obviously, you'd have to play with that if you have the opportunity to put, a cladding on there or something like that. You'd just play with that number a little bit. But you could put it right on the property line, I guess, but you're just not given any construction tolerance. So I think the 25 millimeters is reasonable for that. Okay, so how is this insulated? What I've drawn here is generally how it might be done in a normal instance. It's not good, so we will improve this for sure, but this would be the cheap and nasty, I suppose. So again, this is assuming you don't have access to the other side of the wall and you can't insulate on the outside. So I've just left an airspace here, so 25 mil airspace or so, and then a steel stud wall is built around the steel column, which is right there. And of course, there'd be beams above that the studs would go to the underside of. So steel stud wall just gets built, and you would insulate but in the cavity spaces of the steel stud wall. If it was minus 20 out here or something like that, then this surface right here would be cold on that concrete block, so you wouldn't want some warm moisture-laden air getting to that surface. So I've added in a vapor barrier as well. So that would be the cheap and nasty, I guess, normal way that, or a way it's been done, I suppose, in the past. I have certainly seen it done that way. So basically, it's like a basement wall in a house, essentially, except it's even worse because you're using metal components versus wood components, and you're going to have more conductance through the metal, and you're going to have more heat loss through all these metal components, not to mention, of course, the beams above as well. You could insulate around the beams a little bit, but you're still going to have some inefficiencies there for sure. So one simple thing that could be done to improve this is just instead of the airspace, you could actually put in here a you know, a 25 mil or 50 mil of a rigid insulation right against the concrete block. And so that would be a really, I suppose, simple way to improve this wall. But kind of going forward with that concept, maybe there's a better way to do this, because most times when you see these walls, this would be a commercial use on the inside. So you don't really know as the landlord, I suppose, what's necessarily happening inside this building, and this wall here could be getting beat up pretty bad and getting holes in the vapor barrier and whatnot. So maybe there's a better approach to this. And so maybe a better approach would be to do it this way and just, depending on what your energy code requirements are, put in 2 or 3 layers of a rigid insulation, so an XPS type insulation. I say do multiple layers because you're going to have joints between the boards and you can stagger the joints. This thickness of an XPS insulation is going to essentially work as a vapor barrier. So all you'd really need to do is tape up all the joints on there, and essentially you've just got yourself a vapor barrier right there. So you're not going to have to worry about any condensation happening right there. And I've moved the steel in a little bit more, obviously, to accommodate that insulation so that I'm not, reducing the insulation at the column. So you have to check if that's going to be doable. So there's the steel column right there, the HSS column. And then I've built a stud wall around that and put some gypsum board on there. And the beauty of this is, again, like you don't know what's happening inside that space necessarily. So this wall could get beat up pretty bad, and no one's punching holes through your building envelope. Essentially, it's just a furring wall on the inside, and probably, oops, I erased my tape on there, but you basically probably have a pretty safe building envelope, I suppose. Now, there's going to be challenges for the detail where this wall meets your conventional wall with the outside insulation on the 2 ends or whatever, but that's just a detail that has to be worked out. But probably if I was doing a project right now where I didn't have access to this side and we knew we were going to use a concrete block instead of poured concrete, I would probably look at doing this approach. And then, so just looking back at this picture, yeah, you just have to pull that steel in a little bit to make that work. And people will always say, well, could you use spray foam insulation? Because it acts, if it acts as a vapor barrier as well, if you're using the right spray foam. Yes, you could. I wouldn't. Just do your homework on how environmentally friendly insulations are, and at this point, spray foam is going to be by far the worst. And so I only use it when I really, really have to, and I really have a tricky situation. That's really hard to insulate with conventional insulation. So if it's easy, where this is quite easy, it's very accessible, then I would not be using spray foam personally. And so back to this wall. So this wall here was built with it is just non-combustible construction. So a steel stud wall, basically, with a steel superstructure, and the fire rating was put on the inside. Essentially, there's a couple of layers of gypsum board put on the inside to get the required fire rating. And I'll just finish this video up with an interesting project I was watching get built. And and this just demonstrates, yeah, that you don't have to do the masonry wall. So I was biking around one day and I just noticed this building getting built, and I looked at this and I was like, oh, this is interesting. So there's a stair core or something right there, or elevator core. So that's why that's concrete there. But then I saw that they were doing steel stud on this wall right here. And if you look close there, you can see there's some insulation going in the stud spaces right there. And if you look close, there's a building right here. And so how close is that adjacent building? Very, very close. Like there was not enough room. It was like literally there was maybe a 400 millimeter space between the existing building and the new building. So when I looked at that, I knew like you're not getting a person in there to put sheathing on here or whatnot and finish this wall off. So I looked at this with great interest. I also noticed that the all three other sides of this building were pretty much complete, well, done, like literally done. Like they're not done in this picture, but this sat like this for a long time. And the rest of the building essentially got finished. So in my mind, I was like, oh, I think somebody's made a mistake here, and I think they've missed noticing that you can't actually get a person in here to finish off this wall. And there's some other hints to why I think maybe that happened. Like, I don't know for sure. Maybe their outcome was exactly what they had planned, but I suspect not, because one of the hints was this insulation in the stud space right here. So anyways, they had this wall built here that was steel stud, and they had no way to finish it off for, not a large portion of it, but large enough, like an area down here that you couldn't finish it. And so I sat there thinking, well, what are they going to do? Like I honestly, I wasn't coming up with any ideas, so I was watching it with great interest to see what they do. And what they ended up doing was using a freezer panel, so an insulated metal panel. And so here you see that panel go in. So an insulated metal panel is it's a prefabricated insulated panel. So there's a skin of steel on one side, insulation, and a skin of steel on the other side. And it's a complete wall system basically. So it's your vapor barrier, it's your moisture control, it's everything. So the reason I thought that this wasn't the original plan is because they started to put insulation in the stud space. And if you're using a freezer panel, you don't want to put insulation in the stud space, because the inside layer of that freezer panel, that's what I call it, or insulated metal panel, is a vapor barrier. It's a metal layer. And if you insulate in the stud space, you're making that inside face of the insulated metal panel colder. So you wouldn't want that, because then you might again get condensation forming. So if you were going to insulate the stud space in front of this insulated metal panel, then you'd probably want to put a vapor barrier on the inside. And then all of a sudden you've tanked your wall, because you have a vapor barrier on the inside, and the metal on here is going to be a vapor barrier as well. So I have a feeling they put I hope they did. I hope they put the insulated metal panels up and took that insulation out. I think it sat only partially insulated for a while, because I think they realized at some point, yeah, we got a problem here, and came up with this solution, which was pretty clever. So they obviously craned it down, fit it into this tight spot right here. There's a picture giving you a pretty good idea how tight that spot was. And so normally you would install this stuff from the outside, but they just obviously somehow figured out how to do it from the inside and attach it to the superstructure of the building. And in this picture here, you can see that so these panels come with a styrofoam insulated core as well, but this would have had to have been a non-combustible wall with non-combustible cladding, so they've switched to a mineral wool core inside that panel system. So not pretty, but a solution, I guess, that worked. So again, that's just another example though of where it was not a masonry wall being built on a property line. But again, as I said earlier in the video, 9 times out of 10, I'm seeing it built like this. Okay, so that's the story of, I guess, a firewall that's sometimes not it's a firewall that's not really a firewall, but we build it like a firewall. We call it a firewall, but sometimes it's not actually built as a firewall, and it doesn't have to be a firewall. And so next time you're out and about, pay attention to what's happening, and yeah, put some comments in the chat. I'd like to be curious to know what other approaches people are seeing out there. But that's kind of the history of why we're, or I guess, of how we do these walls where I live.